Okay, welcome to the start of subtopic 5.2, reactions of acids and bases in topic 5, acids and bases. This video will focus on the first row of this table that you can see. So as understanding what we'll be talking about is the oxides of nonmetals are commonly acidic and generate oxyacids when dissolved in water. And by the end of this video, what you need to be able to do are two things. One, draw structural formula for CO2, SO2, and SO3, as well as H2SO3, H2SO4, and H3PO4. So structural formula for them. Two, write equations for the reaction with water of CO2, SO2, SO3, and P4O10. Okay. Before we go into the details of acidic oxides, let's talk about what's oxide to start with. So oxides are the substances which were produced by letting something react with oxygen, really. So, for example, if carbon, well, it's like charcoal, if you burn them, burning in chemistry really means it's reacting with oxygen. So, that's oxide that you are creating. Now, hope you all know that carbon and oxygen would produce carbon dioxide if there was enough oxygen. Sulfur is something that you can also burn as well. There's a process called roasting in mining world, and the roasting usually gets rid of certain things like sulfur, and sulfur can be burned, i.e. reacting with oxygen to create sulfur dioxide. Nitrogen can do the same. Nitrogen dioxide or nitrogen trioxide, sorry, not trioxide, nitrate ion can be coming out. They're all oxides. Oxides are classified as acidic, basic, or amphoteric. Now, hope you remember from previous videos that amphoteric means it can act as base or acid, base and acid, depending on what it's reacting with. This classification is based on how they react with acids and base. So the oxides can react with acid or not, base or not, as well as water. So when acidic oxide reacts with water, what would it do? That's what we're talking about in this video. So acidic oxides, when they react with water, what do they form? They will form what's called oxyacids. They will make acids, oxyacids. Non-metal oxides are they will generally make acidic oxide. Okay, so that's highlighted in orange color. So make sure you highlight it on your note as well. Non-metals oxides, they are commonly acidic oxides. Meaning, when they react with water, they will make some sort of oxyacids. All right. So, example: sulfur dioxide. So, SO2 is something that you were looking at before here. Yeah. When SO2 reacts with water, what happens is it creates H2SO3. Namely, this is called sulfurous acid, and what you can see is it's an acid that contains oxygen in it, so oxyacid. Because it's an acid, it can also react with bases, so any solution with hydrogen ion. Oops. When acidic oxides react with a base, it produces what's called oxyanions and also water. So that's a general formula. Oxyanion, anion with oxygen in it, and water. For example, carbon dioxide and sodium hydroxide. When they react, what happens is it creates sodium carbonate. That's ions in the solution, but the sodium carbonate is going to be produced as well as water. So equation-wise, how does it look like? So carbon dioxide reacting with NaOH. Now it will produce Na2CO3 plus H2O. It's not balanced, so let's balance that. You would need 2 of that for sure. There are 2 OHs, and there's 1 oxygen used up. There's second one. So in total, there should still be 1, 2, 3, 4. 1, 2, 3, 4. I think that's all balanced now. Okay. Now, this equation can also be written as complete ionic equation. So let's also do that. And it's a good practice to remind yourself about what ionic equation as well. Anyway. So that's a full reaction for all the substances that were involved. Now, hope you remember the first step. You need to firstly write all the states. Sorry, not the states, sorry. Separating all the species. That's an ionic solution. So, sorry, ions in the solution. So I separate all of them into ions. That's a reactant. Here, Na2 and CO3, they're separate. They can be separated into ions. So 2Na plus and 1CO3 2 minus. H2O cannot be separated, so that's that. Now, that's not the end. What you have to think about is which one is spectator ion. Na plus, numbers haven't changed. They can be gotten rid of. So, second final step would be to write down what's left of it. So those 4 species have left. Final step. Now, you need to write states. Any ions will be dissolved into water, but water itself should be liquid. So that's the complete ionic equation for that. Okay. Now, if you look at Essentials page 200, table 5.03, you can find common non-metal oxides there. Now, by looking at them, well, any of the structure, name of the oxides could be given in your test. What you need to be able to do is to use those oxides to write the equation, reaction with water, as well as you need to be able to write the structural formula of it. Just one example, say if you had sulfuric acid, H2SO4, if you are given molecular formula, you need to be able to write the structure for it. Sulfur, well, sulfate is an ion, so that's something you should think about. And oxygen can make 2 bonds. So one is bonded to hydrogen, and one is bonded to sulfur, and the other side as well. So here you have H2SO4, but written in a structural formula. Practice doing that with, say, carbon dioxide or carbonic acid, nitric acid, all that was in this slide. So student intended learning part, you need to be able to draw structural formula for all those species. All right, have a go.